Hello students, welcome to Educate. Today we are going to see one numerical based on energy conservation principle. So let's read the question together and then we will try to solve it. A bob of mass m is suspended by a light string of length L and it is imparted a horizontal velocity v0 at the lowest point A such that it completes a semicircular trajectory in the vertical plane with the string becoming slack only on reaching the topmost point C. This is shown in figure. Obtain an expression for v0, the speeds at points B and C, and the ratio of the kinetic energies kb to kc at B and C. Comment on the nature of the trajectory of the bob after it reaches the point C. So here we have to apply energy conservation principle. So energy conservation principle applies only when all forces are of conservative nature. So let's see what is happening here. So how we can apply energy conservation at different points. So one point is here, another point is here. At this point, velocity is v0. At point B, velocity is vb. At point C, velocity is say vc. And the radius of the circle is L. Now, here what we can do, at point A, total energy will be just kinetic because this is assumed to be lowest point. So total energy at A, so EA will be just half mv0 square. Now, one more thing we are going to see here, what is tension? So here body is moving in circular path, it means there is centripetal force. So its weight will act in downward direction. This is bob whose mass is m. So weight will act in downward direction and tension will be in upward direction and body is moving in circular path. So net force will act in towards the center and that will be equal to T minus mg must be equal to mv0 square divided by L, or tension will be equal to mg plus mv0 square upon L. We have calculated the energy at this level, we have found the tension at this level. Now, let's see point C. So, what is the situation at point C? Here height is 2L, so potential energy will become mg into 2L and its velocity is Vc. So, we can say total energy at point C will be equal to half mvc square plus 2 mgl. Why 2 mgl? mgh, h with respect to this point, this is at height 2l, that is why mvc square into 2 mgl. Now one more thing, at this point, since bob or string becomes a slack, it means there is no tension. So just centripetal force will be provided by its weight. So we can say at this point mg must be equal to mv0 vc square upon L. Right? So what you do, just take this value mvc square from here, mvc square equal to mgl, and write it here so that you can get total energy at this point. So total energy at this point, total energy at C will be equal to 1 by 2 mvc square will become mgl plus 2 mgl. So total 5 by 2 mgl. So this is total energy at C, but according to energy conservation principle, energy at A must be equal to energy at C. So we can equate the two. So we write 1 by 2 mv0 square must be equal to 5 by 2 mgl, from where we can get v0 equal to square root 5gl. 5gl. So we have got the value of velocity at lowest point. So we have got v0 equal to root 5gl. Now we have to find out what is velocity at point C. So at this point, so we have seen that there is no tension. It means mg equal to mvc. Here we can write mg must be equal to mvc square upon L. So from here we get vc square equal to gl or vc equal to root gl. So we have found velocity at point C as root gl. I think there is no doubt. Now at point B, so point B will be at height L. So at this point, say velocity is Vb. So total energy at this point should also remain conserved. So we can say total energy at point B, say this will be equal to velocity half mvb square plus its height is L. So mgl. But total energy must be equal to energy at point A here, and it was half mv0 square. So we can say half mv0 square must be equal to half mvb square plus mgl. Now here m can be cancelled and we can multiply each term by 2. So we will get v0 square equal to vb square plus 2gl. Our concern is to find vb. So v0 we have found as 5gl under root. So here just write 5gl equal to vb square plus 2gl. So vb will be equal to 3gl under root. So we have found velocities at 3 points. Now suppose we want to compare kb upon kc. kb upon kc. It means half m vb square divided by half m vc square. So it is simple, half m will cancel out. So vb square divided by vc square. vc square is just gl and vb square is 3gl. So 3gl divided by gl. So ratio will be 3:1. So this is the case. It is a simple question and I think you have understood it fully. Now here final interpretation is at point C the string becomes slack and the velocity of the bob is horizontal and to the left, as you have seen. If the connecting string is cut, then what will happen? Then body will go tangentially. The bob will execute a projectile motion, but since there is effect of gravity also, so it will follow the trajectory like projectile follows. I think you remember, like if projectile is given horizontal velocity, then it moves like this. The same will happen there also. So with horizontal projection akin to the rock is horizontally from the edge of the cliff. Otherwise, the bob will continue to its circle. If string does not become slack, then it will continue to move in circular motion. So I think thing is very clear. Now we are going to consider the situation of a spring. What happens in different cases? Suppose this is a spring and its natural length is say L and here is one mass And now if we apply some force on it, there will be extension in it. Say suppose this is new situation, so we can compare that what extension has taken place. So here extension is suppose x. So here it is found that F proportional to x means applied force will be directly proportional to extension, or F equal to minus kx. So here negative sign shows that there will be a restoring force which will try to regain the shape of the spring, and k is a spring constant. So spring constant is in magnitude will be F upon x. Unit will be Newton per meter. Now this is force. We can find out the work done when spring is compressed or stretched. So work done can be found by integration f dx, and we can put f as kx in magnitude kx dx. And if you remember, I told you integration x power n dx becomes x power n plus 1 divided by n plus 1 plus c. So same thing will happen. This will become k times x square by 2, and we choose integration constant c as 0. So we get work done like this. So here in effect, if we take a negative sign, in that case it will be, as you know, that minus kx square upon 2. So the same thing we can see from these graphs. Here situation is shown when this is normal position, so there is no force, there is no extension. Here spring is pulled in this direction, so there is elongation, although restoring force will be in backward direction. That is why it is written Fs is negative, x is positive. Then further, suppose spring is compressed, then there will be one force which will try to regain the original shape of the spring. That is why here Fs is positive and x is negative. Negative means from this position it is shifted towards left. And as you know, F equal to minus kx. So if you plot the graph, you will get this straight line, and area can be found. This is original position, this is maximum elongation. So area of this portion will give the amount of work done, and since this is below the axis, it is negative. So area will be, you can evaluate whether it is minus kx square or not, that we have got through integration. If we calculate the area here, so this is 0, this height we can find. So here if f equal to kx, so area of triangle, so what is base? Base is x, and what is height? So height will be, so area will be a equal to 1 by 2 base into height, right? So what is base here and what is height here? So corresponding value of force we can write, and base x, so 1 by 2, and this is minus kx times x. We are taking this force, so force as kx and times x. So because this axis is force axis, so corresponding to this value you can take force, so you can write it as kx normally, and then you will get same thing. Now Here it is shown that if you pull pull the spring up to certain distance, then you will leave it back, then it will go to original position. So total work done in that case will be 0. That is calculated. So in two positions the work will be of different nature, so this is how it will get cancelled. So spring force is, we can say, it is path independent and it is conservative force. Later on I will tell you these things in detail. So here, when there is one case when spring is suppose this is position of original position, and now suppose it is pulled to this position. So here there is elongation of x. So potential energy, we have seen in earlier case work done, and work done is always stored in form of potential energy. So potential energy of a spring will be half kx square. And suppose we want to find out what is the maximum velocity when it is released. So for that we can say total potential energy stored in the spring must be equal to its kinetic energy, mv square. So from here we can get what is its velocity. So velocity can be found by v square equal to k upon m times x square, or v equal to root k upon m times x. So this is value of maximum velocity. Here one more important thing you must understand, that we can apply energy conservation again. Same thing happens when here I'm making diagram little larger so that you can see it clearly. So here what is happening, this is total energy, that is kinetic energy plus potential energy, and here this is curve for kinetic energy, this is curve for potential energy. Now what is happening, when kinetic energy is maximum, then potential energy will be minimum. We can refer the case like suppose you take a simple pendulum. So what happens, at different positions we can find the energy. These are extreme positions where velocity will be 0, it means kinetic energy is 0, so only potential energy will be there, potential energy will be maximum. So these are the cases where extremities are there like xm. In that case what happens, at the extreme position, unlike the case of pendulum, velocity will be highest for spring. So if velocity will be highest, it means it will have highest kinetic energy. In that case potential energy will be 0. Now after some time its velocity will start decreasing, and at mean position, suppose velocity becomes 0, here this is that position, in that case its kinetic energy will become 0. I think I confused you, so it is better to tell other way around. Here you can say this way, that here this is potential energy curve at mean position, here potential energy becomes 0, right? At extreme positions potential energy, since the spring is stretched, so it will have maximum. Let's write it here. So situation is like this, you will understand easily this case. So if it is stretched to distance x in this direction, so that is shown here, the potential energy will be highest, or it is compressed to this position, then potential energy will be again highest, corresponding to this minus xm. This is positive xm, this is negative xm, right? So here what is happening, If potential energy is decreasing, it means kinetic energy will start increasing. If one decreases, another increases because energy remains constant. At the point when potential energy is zero, kinetic energy is maximum. So sum of total energies, sum of the two, kinetic and potential, remains constant. So here this graph shows the same thing as the energy conservation. So I think you have understood. Now let's see one question. To simulate car accidents, auto manufacturers study the collisions of moving cars with mounted springs of different spring constants. Consider a typical simulation with a car of mass 1000 kg moving with a speed of 18 km per hour on a smooth road and colliding with a horizontally mounted spring of spring constant this much. What is the maximum compression of the spring? So here the information given we can note and then we can calculate. So what information is given? Information is that mass is given as m equals 1000 kg and velocity is given as 18 kilometer per hour. So multiply it by 5 by 18 to convert into meter per second. So 5 meter per second. So you have two information. Now we can find its kinetic energy. So what is kinetic energy? Ke equal to half mv square. And since there is a spring here, so maximum compression means total energy stored in the spring, that is half kx maximum square, must be equal to kinetic energy. So what we do, we can write it 1 by 2 mv square must be equal to 1 by 2 kxm square. In our question, k is given, so there won't be difficulty in evaluation. Now 1 by 2 will cancel out, and then what do we get? So cancel 1 by 2 from both sides, and we have to find out this compression. So xm square equal to m upon k times v square. Put the values. M mass is given as 1000, velocity is 5 square divided by spring constant is 5.25 into 10 to the power 3. 10 to the power 3 will cancel from here. So 25 by 5.25, and then you can evaluate 25 divided by 5.25. So you can do calculation and you will get the answer. Here answer is 2 meter. So will it be so? I think it can be so. I have not done full calculation. Let's check it once so that you may not have problem. So we have 1 by 2 mv square equal to half kx square. So here 1 by 2 cancel out. This is 1000. This is 5. Velocity was 18. So 5 into 5 equal to spring constant was how much? It times x square. So let's see what is spring constant here. Spring constant is 5.25. So calculation that we did, that was correct, and just do, you will get x equal to 2 meter. Now, let's proceed to next question. Here, next concept is there is one question. Consider example 5.8 taking the coefficient of friction. In previous question, we have not considered the concept of friction. But here in our question, it is given that mu equal to suppose 0.5. Then calculate maximum compression. So if we take into consideration the here friction also, in that case, what will happen? The compression will be less. Logic is very simple because in that case there will be a force that will reduce total energy. So let's see what we are getting in this case. So total kinetic energy, as we have calculated in previous case, so 1 by 2 mv square must be equal to work done or potential energy of the spring, that is half kx square, and also work done by frictional force. And what is frictional force? Frictional force is given by mu mg, and here distance through which mass has moved means the compression or extension is taken as x, so it will become mu mg x. So this is kinetic energy, and values are given. M is given, and other informations are given in your question, and your question is to get x. But here there is one important point. The point is question is going to be complicate. So let's solve it. mv square equal to kx square plus 2 mu mgx. Now we can further write it as kx square plus 2 mu mgx minus mv square equal to 0. And our concern is to get x. So for this is quadratic equation in terms of x. So we can apply formula. If you remember, ax square plus bx plus c equal to 0. So x equal to minus b plus minus root of b square minus 4ac divided by 2a. So the same thing we can apply here. So if we apply the formula, so we can get the value of x. So x will be minus b. So negative of 2 mu mg plus minus. If we write minus, then extension has no meaning. So here we will write plus, so that this value should be after getting square root, this value should be larger than this. So overall value should be positive. So root of b square, square of this 4 mu square m square g square minus 4ac. So minus, here there is minus sign, so it will become plus. 4a is k and c is mb square divided by twice of k. Now here each term contains 2, so this will give 4. 4 means 4 can be taken out, so it will become 2, and in every term there will be 2. So this 2 gets cancelled. So we will get x equal to minus mu mg plus root of this is mu square m square g square plus this is k mv square divided by k. Now we can put the values. Values are given, like value of mu is given, m is given, g you know, and here velocity is given and spring constant is given. So after putting the values, we will get x equals 1.35 meter. So in previous case, it was 2 meter. Here it is 1.35 meter. So you have understood. Here we have taken into consideration non-conservative force because friction is non-conservative. So that is why this value of x is this. Thank you, Team Educate.